So today we're going to graph a parabola, and it's based on the standard form of that parabola. And you recall standard form has two different types. Type 1 is when x is being squared. When x is being squared, then the parabola is either going to go up or down. So again, if this is me working on this problem and I'm trying to graph a parabola, once I see x is being squared, I immediately know it's either up or down. The second thing I need to do to establish whether it's up or down is establish what p's sign is, whether p is positive or negative. So if p is positive, it's going to be up. If p is negative, it's going to be down. Okay? And I'm only writing the x squared structure here because that's what we have happening here, right? So recognize if it's in standard form already, what's being squared should be pretty obvious, so you know what standard form we're working with. Okay? So I need to find out 4 specific pieces of information. These pieces of information are as follows. I need to know what h equals, what k equals, what p equals, and what direction the parabola goes, up, down, left, or right. If I have those 4 pieces of information, I can then plot the parabola very easily. So here we go. In our equation, I'm going to write this below here. I've got x minus 2 parentheses squared equals 6 parentheses y plus 2. I want you guys to compare the standard form structure to the standard form structure actual that we have in our problem versus the general standard form structure up here. H is paired with x always, k is paired with y always, and 4p is whatever's in front of the non-squared object. That's where you locate the things you need to know. Where's h, where's k, where's p? They're going to be right where they're supposed to be if it's in standard form. I want to identify those 3 values, so h equals something, k equals something, p equals something. So this says x minus h. Anytime you see minus in a mathematical formula or structure, it means whatever number you're looking at is the wrong sign in the structure. So x minus h, this says x minus 2, h is going to be positive 2. Again, a minus in the structure tells me the sign is not the right sign, change the sign. Y minus k, y plus 2. K is going to be 2, but it's minus k, so this is the wrong sign, so k is going to be negative 2. Finally, 4p is whatever this number is. So if I say 4p is equal to 6, and notice that's a positive 6, that matters. 4p equals positive 6. Divide both sides by 4, p is equal to positive 1.5. I want you guys, every time you do these problems, to have a plus or minus sign in front of p, because that really matters. Okay, signs matter for the vertex also. HK signs matter, but not as much as they matter for p, because p is either positive or negative, and its sign establishes what direction this parabola is going to go. So again, as soon as I saw x squared, I knew up or down were only 2 choices. And once I know up or down are only 2 choices, now I need to figure out which one it's supposed to be. Well, now p is positive 1.5. If p is positive, it goes up. So this is an up parabola, not a down parabola. Okay. Now, just to refresh your memory on what we saw last week about graphing parabolas and the graphs of parabolas themselves, an up parabola looks like this. It's got a parabola shape. There's the vertex. There's a focus in here somewhere. There's a directrix that runs horizontally, and there's an axis of symmetry that runs vertically. Right? That's what a parabola looks like. It's got a vertex, it's got a focus, both points. It's got a directrix and an axis of symmetry, both dashed lines. And the last thing it has is 2 extra points that I told you about. We're going to find a point here and a point here. That is exactly 2p spaces, where p is this number 1.5. So, once I know all this information, here's h, k, and p, and I know it goes up. Once I know all that information, I'm ready just to plot my parabola down. Here's how we do it. The vertex is h comma k. H is 2, k is negative 2. That's my starting point. That's where everything comes off of. So I'm going to go 2 right and 2 down from the origin. I always plot points from the origin. Use the ordered pair to establish direction. P is positive 1.5. P is how you get to the focus from the vertex. This is the vertex. Positive 1.5 goes up. And again, my choices are either up or right, but again, I've already established it goes up. That's what the up tells me. Where's my focus going to be related to my vertex? Okay, once you've plotted both the vertex and the focus, the directrix goes the opposite direction. So if the focus went up, so the directrix is going to go down. How far? 1.5 down. So if I'm here, 1.5 down will be here, but again, the directrix is a line. So we do a dashed line to represent the directrix. Again, for an up-down parabola, the directrix is horizontal. The axis of symmetry is vertical, and it passes through the focus and the vertex. So I draw my axis of symmetry in like so. The last thing I need is 2 more points. I know P is equal to positive 1.5. I want the absolute value of 2P. Okay, I don't care if P is positive or negative. I want this number to be a positive number. So what's 2 times 1.5? 3. So that's how far I'm going to move from my focus. Again, this is my focus right here. I'm going to move 3 to the right and 3 to the left to get 2 extra points. Again, 2P to the left, 2P to the right from the focus. This is the focus right here. You can also take half of that number. Half of 6 is 3. So either go 3 left, 3 right, because half of that, or double that. Take your pick. It means the same thing. So once you get your 2 points and your vertex, those are the points that are going to connect to make the parabola. So you can just connect the dots with a smooth curve through those 3 points. Okay. Mathematically, when you're graphing things, the graph is the solid line. Everything else that's dashed represents some sort of a boundary or some sort of thing, part of a definition. Those types of things happen. So that's why the directrix and the axis of symmetry are not graphed as solid lines. They're just boundary values and points of interest that aren't part of the actual graph. All right? So that's the whole process. Standard form happens. You pick the right standard form. You say it's up and down because x is squared. You say it's left and right because y is squared. Once you establish that, then you look at P's value to establish whether it is up or down, or whether it is left or right, depending on which standard form it was. Plot your vertex, go the right direction for everything else, and you're good to go. All right? So that's the whole process.